Okay, I'm out again today. I'm sorry. I know it stinks. But anyway, we're going to go through a lot of this very, very quickly because it's review. We went over a lot of it yesterday. However, some of the stuff was really complicated. Most all of it was completely new to you. So let's just blaze through some of this stuff real quickly. Remember, ions are charged particle. If you lose an electron, you become positive. If you gain an electron, you become negative because you have more negatives. Remember, it's a cation if it's positive, it's an anion if it's negative. Great. So how do these form? Well, like here in the sodium chloride, the sodium, which has got one valence electron on the outside, it gives up its electron. So if it gives up its electron, that means it's going to be overall positive. The thing that gains the electron, the chlorine, is going to be overall negative. And yes, that's awesome. Let's keep going. Now, remember we said electrolytes, those are things that have sodium in them, things that make ions when they're dissolved in water. Those are electrolytes. Electrolytes can conduct electricity. Good. Let's keep going. We said that you need to have electrolytes in your body, especially if you're working out or if you're running, because the sodium-potassium pump in your cells needs to keep on switching back and forth, and you need to have the sodium, which is the salt that you drink. Remember, bananas, potassium. That's why a lot of runners, they eat a banana before they run. I don't run, so not a problem for me. Let's keep going. He needs some electrolytes, and he needs a banana. Remember, we said that ions in a solution, that's why batteries always have a liquid or at least a paste in them, because the ions are able to go to one side or the other based on the chemical reaction. So if you have a whole bunch of positive ions on one side, that means you've got a positive side of a battery. If they move away from the other side, that means you got a negative side to a battery. It turns out ions in a solution is what makes batteries. Remember, good electrolytes, they can conduct electricity. Bad electrolytes, like pure water, distilled water, that cannot conduct electricity. So it needs to have a certain amount of ions in it, which remember is from the dissolved salt. So how do the ions form a solution? Remember, there's two ways. One way is ionization. And an ionization, basically, it's a chemical reaction. And what's happened here in this particular case, the hydrochloric acid, the HCl, has lost its H. The H has been ripped off, and it's over here to the H2O. So now we've got H2O with another H, which makes it overall positive. The chlorine, on the other hand, has gained an electron, therefore it becomes overall negative. That's ionization. So essentially a hydrogen gets ripped away. And then there's dissociation. And dissociation, think of it like a whole bunch of magnets. And with the magnets, you've got magnets like surrounding each one of these positives and each one of these negatives. I might be able to show you that here in a second. Give me 1 second. Okay, so it turns out I can show this to you. These are buckyballs, which are like little magnet things. Let's see if I can make this a little bit larger here. So there we go. So these are buckyballs, little magnet things, and this would be a good representation of a salt. With the salt, let's suppose we had one dark buckyball and then one light buckyball, and they're stuck to each other because they're magnetically stuck to each other. The same thing with the sodium and the chlorine. The chlorine would be negative and the sodium would be positive, and it's the positive and negative that makes it stick together. Well, here's the deal. If we were to put this into a solution of all sorts of water, and the water actually had stronger magnets, it would start to peel these pieces of magnet off one by one. And as it peels these pieces of magnet off one by one, it starts to get dissolved, and that's called dissociation. So it's just like a whole bunch of magnets and stronger magnets taking it apart. By the way, these buckyballs, it's really kind of interesting story. Two kids apparently ate some of these buckyballs, had some digestive issues, and something went bad. So Ohio Senator Sherrod Brown, as part of a child safety board or something like that for child toys, and these are now illegal to purchase or to sell, these buckyballs. And that's really ridiculous. They're just fun magnets. But anyway, Some kid eats them, now you can't buy them. Okay, let's move on. Hopefully that helps out a little bit with the dissociation. Okay, let's keep going. So remember we recapped, we said there's ionization. It revolves the creation of charges. Dissociation, it's breaking up bonds due to the weak bonds. Yes, I spelled weak wrong. Let's continue. Okay, so this is where we left off yesterday. We said that there's the effects of solute particles. It turns out that solute particles can affect the properties of a typical solvent. Nuh-uh. Yeah, they can. So the solvent's properties would change. Let's use this as an example. If you add salt to a typical solvent like water, water acts differently. So if you put salt in water, it says here that a certain solute like salt prevents crystalline structure of ice from forming at 0 degrees Celsius. So we know that typical water, it freezes at 0 degrees Celsius, not salt water. Because when the salt is in the water, remember, let's use our buckyball here. Let's pretend that these are a bunch of water molecules. But if we add salt in there, now these water molecules are actually spaced out a little bit because there's salt in between them. And it can't form its ice structure. And since it can't form its ice structure, it actually has to get significantly below 0 degrees Celsius in order to freeze. I think it's like -2 or -3 Celsius. Before it's going to freeze. So salt must be colder than 0 in order to turn to ice. So the weird and ironic thing is, in the wintertime, when they put salt on the road, they're actually making the ice colder, but turning it into a liquid, which is kind of weird to think about. So it says it makes ice colder, but it makes it a liquid. Or I don't know if you guys have watched the Titanic. In the Titanic, there's Jack and there's Rose, I think. And they, Jack, I don't want to ruin it for you. Hopefully you guys have seen it. Forgive me if I ruin it. Jack, he sinks in this water, and the water's salt water, and he's developing some ice and stuff like that on his hair. But what a lot of people don't understand is, because it's salt water, it actually was below freezing. So Jack would have been warmer if he was actually trapped inside an ice cube. But since he was in salt water, it was actually below the freezing point. So talking about hypothermic, I mean, you get crazy hypothermic super fast. Like I said, it would have been significantly warmer for him to be in an ice cube rather than be in that ocean at that point, because it was really, really, really cold. Anyway, let's keep going. Here's some more examples of the effects of solute particles. Instead of lowering the freezing point, which salt does to water, you can raise the boiling point. Solute particles block part of the surface and prevent water molecules from escaping as steam. Take a look at this. Over here we've got regular water. These are water molecules, and this is water molecules after they've turned to steam. No, they really don't change size, but just for the sake of argument, we can see that these water molecules are leaving. However, on the other hand, if we add some, what do we call that stuff? The antifreeze. If we add some antifreeze to this, you can see those antifreeze are represented by the pluses. Now the water doesn't have like complete access to the surface. Can water get to the surface? Yes, it can. But can it get to the surface as easily? No, there's these pluses blocking it. Therefore, it cannot boil as quickly. So if you add antifreeze to your car, you can get the water well above 100 degrees Celsius before it boils. I forget exactly what it's going to boil at, maybe like 110 Celsius. So essentially you're like superheating water. Antifreeze also does the reverse. It prevents it from freezing, so you can drive your car or your truck when it's really, really, really cold and your radiator is not a block of ice. So if you've ever mixed antifreeze before, if you've ever put it in a car, you'll know that you can buy pre-mixed antifreeze or you can buy antifreeze concentrate. And with antifreeze concentrate, you pour half of the antifreeze concentrate in and then you add water, because it's going to be the solute solvent kind of mix, and the antifreeze is going to be the solvent, or the solute, I'm sorry. Because the water is the solvent, it should be there in greater quantity. So you kind of mix those things, and it changes the properties of the water. The water doesn't freeze when it gets super cold, and the water doesn't boil when it gets super hot, because you've added the antifreeze. Okay, that's all I've got for you today. I think Miss James has some worksheets for you guys to work on. I'll be collecting those on Monday. Have a great day.